Hello, and welcome to our fourth section on polynomials. We're going to talk about factoring polynomials. All right, so we're going to factor polynomials using a variety of methods, and we're going to learn the implications of the factor theorem. Okay, so we're going to factor, again, using many methods, polynomials. So we want to factor by finding a common monomial, and then use what we know about factoring quadratics. So those two steps. So we want to recognize and factor the difference also of two squares in perfect square trinomials. We want to factor by grouping, so we'll go through that. And then it might be a new skill for you. And then factoring polynomials in quadratic form, or I say polynomials that are disguised as quadratics. Okay, so let's talk about the first, finding common monomials and recognizing specific product patterns. So the difference of two squares is a product pattern you're going to run into in different parts of your math career, especially moving forward as you go into pre-calculus and then calculus. So the difference of two squares is just the difference between two squares. So a squared and b squared, where a and b are perfect squares. So z to the fourth is a perfect square. That's z squared squared. Z squared is a perfect square. It's z squared. And 4 is a perfect square. It's 2 squared. So perfect squares can be variables or quantities. It doesn't matter. And we can substitute either one of those in for a minus b and a plus b. Typically, we'll have one variable and one quantity when we're looking at the difference of two squares. We're not going to have two quantities just because then you would subtract and simplify and then multiply. But we also might have two variables. So two variables or a variable and one quantity is how the difference of two squares would be set up. So if you see two terms here that are perfect squares and it's a difference between them, then you have that form a minus b times a plus b. All right, so let's get right into some classwork. This is not due. You're going to do this with me. And again, urging you to try to do this on your own before I give you the answers. So you can check your work as you work along. So I'm going to pause here for a moment. You can pause and then let's see if you can factor each of these three as a difference of two squares, and I'm going to give you the answer. So please pause. All right, so the first one is x minus 5 of the difference of two squares, x squared and 25, two perfect squares, x minus 5 times x plus 5. And then, so this is a variable and a quantity, and x squared minus y squared would be x minus y times x plus y. And then x to the fourth minus 16 is x squared minus 4 times x plus 4. And I have it what's called like a nested or embedded perfect difference of two squares inside of the difference of two squares. So I have x squared minus 4 times x squared plus 4. That's going to factor to x plus 2 times x minus 2. And then this is not the difference of two squares because I'm summing these two values. So we leave it as is. I can't factor this any further. All right, so I first get x squared minus 4 times x squared plus 4. And then I'm going to factor x squared minus 4 into two additional factors. This is a nested perfect square. All right, this brings us to our first classwork problem. So you're going to do these on your own. You're going to submit these into a form or location that I defined for you. So please factor these quadratics as the difference of two squares. I also have a quartic too. So you can pause here and copy these down, and then I'm going to move on. All right, so the next product pattern we want to consider is a perfect square trinomial. That's when you have the same binomial, a minus b or a plus b squared. So a minus b squared ends up being a squared minus 2ab plus b squared. And a plus b squared ends up being a squared plus 2ab plus b squared. And you can figure that out if you were to FOIL both of these, a minus b times a minus b, or a plus b times a plus b. You end up with those perfect square trinomials. All right, so what you're going to look for is some value for b in this case, which is really c in standard form. But in terms of the perfect square trinomial, so that value c, that's a c squared value, a perfect square. So once you see that, the square root of this value times 2 at least when we don't have when we have a coefficient of 1 here, then you're going to have a perfect square trinomial. So this is x minus 3 times x minus 3. That's x squared minus 2x plus 9. Here's a perfect square trinomial. And then x squared plus 4x plus 4 is x plus 2 squared. All right, here's my perfect square. So these are both examples of perfect square trinomials. All right, so let's do some work around this. Let's see if you can factor these. I really should set this, well, I should set these equations equal to 0 or something. So we're just going to factor these three, and I want you to pause again to try to take care of these problems, and then I'm going to give you the answer. So please pause, see if you can work these out, then you'll have some classwork. All right, so this factors into x minus 5 times x minus 5. X squared plus 12x plus 36 is x plus 6 squared. X squared minus 2x plus 1 is x minus 1 squared. All right, so I'm going to bring this to your next classwork problem, 4.4.2. So I'm going to factor these quadratics as perfect square trinomials. So please copy this down, and then I'm going to move on. Okay, I'm going to move on. All right, so now we're going to talk about factoring common monomial first. We want to take care of the polynomial and reduce it by removing any common monomials or common factors in each of the terms. So I have x cubed minus 4x squared minus 5x. We can see that we have an x that's common, x to the power of 1 that's common in each of the terms. So we're going to distribute that value for x out. And so we end up with x times x squared minus 4x minus 5. And then we can factor using other methods. This is a quadratic that we can factor using the diamond and box method. And so we end up with x times x minus 5 times x plus 1. All right, so let's practice this together. So please pause here and see if you can factor this polynomial completely by finding a common monomial first. So I'm going to pause here for a moment, let you work on this, and I'm going to give you the answer. Okay, so I have a common monomials in 3 and y cubed. So I'm going to distribute those out. I get 3y cubed times y squared minus 16. Y squared minus 16 is the difference of two squares. So this becomes 3y cubed times y minus 4 times y plus 4. So you can pause if you want to write this down. I'm going to move on to your next set of classwork. This is 4.4.3, so please copy down the problem. So you want to factor this polynomial completely, first by finding a common monomial. So please copy this down, and then I'm going to move on. Okay, so the next thing we're going to do is we're going to factor by grouping. So let's talk about how that's going to work out. All right, so factoring by grouping. So the first thing we're going to do is we're going to group two pairs of two terms, typically first and second and third and fourth. Sometimes we can also do first and third and second and fourth, but generally not first and fourth and second and third. So first and second, typically, we can also do first and third and second and fourth. So we're going to group two pairs of terms, and some of this is a little bit of play. You have to experiment, and sometimes factoring by grouping doesn't always work out the way that you want it to into a proper grouping, but it's one of the skills that you should have for factoring polynomials. It's one way to factor a polynomial pretty quickly. All right, so let's go through how this works. So I'm going to group two pairs of terms. I'm going to group the first two, z cubed plus 5z squared, and then minus 4z minus 20. And then I'm going to distribute out the common monomial in each of the pairs. In this case, it's z squared. In this case, it's negative 4. And our goal is to make the two binomials the same, so z plus 5 and z plus 5. So if we have that equivalency then, or equality, then we can continue on with the grouping. But if we don't, then it's probably not going to work. So I'm going to take z squared minus 4 times z plus 5. Right? So z squared minus 4 times z plus 5. So this is how this works. And then we can even distribute, have a difference of two squares, z squared minus 4. We can factor that to z plus 2 times z minus 2, and then times z plus 5. So you're going to group the first two, and then I went through the whole process. Then we distributed out the common factors, making that binomial the same, and then we rewrote and completely factored. Okay, so group two pairs of terms, factor common monomials, rewrite the polynomial in factored form. So this is a practice round for you, so please try to do this on your own, and I'm going to give you the answer. Okay, so I'm going to group first and second again. I group the two pairs of terms. Then I'm going to factor the common monomials in each. And then I'm going to rewrite as a polynomial in factored form. So you can copy this down. I'm going to give you one more example, and then I'm going to give you some classwork. Okay, so one more example. Let's see if you can do this on your own. So you can pause here. All right, so I have first and second terms, third and fourth, x cubed minus 8x squared, factors to x squared times x minus 8, minus 4 times x minus 8. And then I can rewrite this x squared times x minus 8 minus 4 times x minus 8, and then that's x squared minus 4 times x minus 8. I have the difference of two squares here in x squared minus 4. So I have a nested difference of two squares in the polynomial, and x plus 2 times x minus 2 times x minus 8. So I've completely factored first by grouping and then by noticing special product pattern. All right. So this brings us to classwork 4.4.4. And I'm going to give you the problem. Please write it down. So we're going to factor by grouping. Let's see if you can do this on your own. And then I'm going to move on. Okay, last thing we want to do is we want to factor polynomials in quadratic form. I say these are polynomials disguised as quadratics. All right, so we're going to factor, I have x to the fourth plus 9x squared plus 20, and this is not a quadratic, it's a quartic, but it's in quadratic form, meaning I have 2, 1, and 0. So 2 by x, 1 by x, and then a constant value. So I have three terms. It's in the form that looks like a quadratic. So we're going to pretend it's a quadratic and factor, and then we're going to rewrite in as a factored polynomial. So I'm going to pretend this is x squared plus 9x plus 20. So I'm going to divide by whatever constant value I need to get this first term exponent to be 2. Right? So I have 2, 1, 0. I'm going to factor this like I would a quadratic using my diamond and box, or just factoring intuitively if I can. And then I'm going to rewrite this factored quadratic by placing back that exponent value that I need in order to make x to the fourth, that first term in the FOIL process, f, be the same. So I have to add another x back in here, so it becomes x squared plus 5 times x squared plus 4. So that x squared times x squared is equal to this first term, x to the fourth. Right? So we view it as a quadratic, factor it like a quadratic, but then add back the proper exponent values to the first two terms in order to make it the same as the original polynomial, at least the same degree. All right, so we're going to try a practice round here for you. So please pause and see if you can do this on your own. And I'm going to give you the answer. All right, so we have, I'm going to rewrite it as a quadratic, x squared minus 3y minus 28. Factor it like a quadratic using my factoring skills. And then I'm going to add the 2 back in here because I want y times y squared times y squared to be y to the fourth here as the first term. All right, 4.4.5. This is your classwork. All right, so factor the polynomial as a quadratic. So please copy this down. And this is going to bring us to the end of our first session. So copy this down. This is your classwork. And I'm going to stop here.